Graphing linear equations, again, those are called linear equations because they make a line. That's what linear means. It makes a line, so it is not going to be shaped like this, which is something you'll see later. It is not shaped like this, which is something you'll see later, or this, okay? It is shaped like a straight line, so it goes like that, or it goes like that. It does not curve. It is a linear equation. Okay, how we figure out what linear equations are we graph them. They are in two variables. That means that they have an x and a y, just like on the last section. And we know that it is linear if it can be written in this form. Okay? This form is called standard form. Okay? This is called standard form. And standard form, there's a couple rules on standard form. First, you need all of the letters on the left side. So all of your variables on the left, and that C is your numbers. So letters on left. Okay? The other thing is A can't be negative. Or a fraction. So if it is either one of those, when you're solving it, you have to multiply to get rid of the fraction. You have to multiply to get rid of the negative. Okay? So when you're solving this, you move all the letters to the left, and you multiply if there is a fraction or a negative starting out the problem. Okay? Alright, so we want to figure out if this is a linear equation in two variables. So we need to figure out if it can be written or is written in standard form. AX plus BY equals C. Is it written in that form? Yes. I don't care that this is negative. I don't care that this is negative. As long as A is not negative. So yes, that is correct. The one thing I didn't point out, so go back to this slide. The one thing I didn't point out is that the variables only have exponents of 1. Okay? And when we have an exponent of 1, we don't actually write that down. Okay? So they have to have an exponent of 1. So if it was ax squared, that is not linear in two variables. Okay? So they have to have an exponent of 1 as well. Okay, what about number 2? Is that linear in two variables? No. Well, it might be. It's just not in the right form yet. So let's move all our letters to the left and see. Okay? So if we add 2x to both sides of this, plus 2x, that'll be 2x plus y equals 0. Now if we look at it, is that in standard form? Yes, so that is still linear in two variables. So even though it's not written at that moment in that way, if it can be written in standard form, then that is still linear in two variables. Okay, what about number 3? What makes it a no? Because the squared is not allowed to be there. So everything else about this is perfect. All the letters are on the left. There's no negative or fraction here. All right, so everything else about that's perfect except for that exponent. The exponents have to be 1, so this is not linear in two variables. That is a quadratic, which is that U-shaped one that I drew earlier. Okay, last one. Is that linear in two variables?
Well, yes, because the y is 0, isn't it?
Yes, so the y's not there. However, it could still be written as ax plus by equals c. So it can still be written that way. So that is still standard form. Okay? Because anything multiplied by 0 makes that go away, and that's still exactly what was written above it. Okay? So that still counts. Okay? So yes, that is linear in two variables. Okay, now we have to graph some stuff. Okay, in order to graph, we actually don't want it in standard form. Standard form is pretty easy when you're making a table, but I don't want you to make a table. I want you to do y equals mx plus b. I want you to do slope-intercept form is what it's called. So I want us to solve for y here. We got to get y by itself. So the first thing we always undo is whatever's being added or subtracted to the variable we want to get alone. So the first thing we want to do is subtract x, and minus x. So negative y equals negative x plus 7. Okay, y is not alone yet, so we need to divide everything by a negative 1. There's a negative 1 before the y, so to get rid of that, we're going to divide everything by negative 1. Dividing by negative 1 is the same thing as just flipping every symbol. So you could also do it that way. So y equals, now that's a positive x, minus 7, or plus negative 7, some of you like to write. Okay, so from here, now that we have it in y equals mx plus b form, that is y equals mx plus b. We want to write down what those two other variables are, what the m is and what's the b. So what is the m on our equation? Slope. And what is that number? 1. M is whatever's before the x. So our m is 1. So down here, m is 1. And what is our b? Remember, it's whatever's being added, so that means that this is negative 7. That is included. If you want to do chunka there and see that that's a negative 7, you can. So b is a point, right? So I'm not going to just write down negative 7. I'm going to write down 0, negative 7. Okay? We have to write it down that way, or else we'll put it in the wrong spot. Okay, so b is what we start at. So we're going to start at 0, negative 7, and then we're going to use our m to get somewhere else. So 0, negative 7. We're going to put our first dot there. Okay, the second thing is our m. Slope is easiest when it's a fraction. That's the only time where fractions make it easier. So instead of 1, I'm going to make that 1 over 1. Okay? And slope is rise over run. So we are going to rise. So this is different than an ordered pair. Ordered pair, you run first. Okay? On a slope, we're going to rise 1, run 1. So rise 1 from that original dot, run 1. So we're going to end up on that second spot. We can continue to do that over and over again to get more dots, but we only need 2 to create a line. So rise 1, run 1. And there is our graph. Okay, so that's what we're going to do every time. We got to get y equals mx plus b, write down what m and b are, and then graph your line from. Okay, so let's try again. Is this in y equals mx plus b form? Yes, it already says y equals. So y equals, we're going to make it look more like a fraction. So what is my m? What is my before x? 1/2. And we like m to be in a fraction, so that's good. What is b?
0.
It's a point. I need 2 numbers. 0, 0. The first number is always 0. Okay, and that's because this says plus b, or plus 0, because there's nothing there. Okay, so our starting point is at 0, 0. Then we're going to rise 1, and then run 2. So rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Okay, if you have not noticed, I purposely misspell rise so that you remember that the y goes on the top. Okay, so the y is always on the top of rise over run. The y-axis goes up and down. Okay, 2 more. Okay, so this is not in y equals mx plus b form, so we have to undo the addition or subtraction first. So subtract 5x from both sides of this. Okay, that goes away over on the left side, so then we have negative 2y equals negative 5x plus 10. We got to get rid of that negative 2 that's next to that y. So divide both sides, every part, by a negative 2. That cancels. So y equals, the negatives cancel out. So we can make this a positive fraction now. So 5 over 2x. And then 10 divided by negative 2 is a negative 5, or a plus negative 5. I'll do it your way. Plus negative 5. Okay, what's my m? 5 over 2. And then my b is 0, negative 5. So the reason I'm so adamant about you writing it as a point like that, instead of just saying negative 5, a lot of people accidentally put that b on this axis. But if we remember that we run to 0 and then fly to negative 5, then you'll always put it on your y-axis. Okay? So we start at 0, negative 5, and then we're going to rise 5 over 2. So rise 5 from negative 5 over 2. There's my second point. Rise 5 over 2. And then we can create our line. The main thing about graphing a line for me is you always run to the right. Okay? So you rise 5, you always go to the right on this. So if there's a negative, you're going to go down, but then still go to the right. Yeah?
I thought you went to the left if it was negative.
So if it's negative, I say, just so it's always consistent, your negative is going to tell you whether to go up or down. And then you always are going to go to the right on your second dot. If you want to go backwards, you would change both symbols. So you go down 5, left 2, down 5, left 2. Like if I made a negative on both. But if there's just one negative, I would use that only as up and down, just so everything's consistent. And then always go to the right. Okay? Last one. So here's a graph of this line. Y equals 2x. And we're going to make sure about that. Y equals 2x right here. Y equals 2x. My m is 2 over 1. And my b is 0, comma 0. So if I go to 0, 0, and then rise 2 over 1, that is true. That is the line that we are looking at. Okay, now we've got a separate line right here. Y equals 2x minus 5. What is the only difference on that line? The 5, the minus 5. So the m is still going to be 2 over 1, but our b is going to change. Our b is going to change to 0, comma, negative 5. So that means our starting point is going to change. So at negative 5, we can put a dot that's between those lines, and then we're going to go up to over 1. Then from there, we can draw our line. So if you're comparing those lines, what word would you use to describe them?
Parallel.
Parallel. That is correct. Okay? Anybody know why they are parallel? Anybody know how we could tell that they are parallel before graphing them? Yeah?
Because they'll never. Wait,
Yeah? Keep going.
they'll never like hit.
Yeah, so they'll never hit. That's the definition of parallel. And then if I was standing right here, and you were just looking at that and that, or that and that, how would you know that they are parallel, James?
M is the same.
M is the same. Perfect. M is the exact same thing. So if your slope is the same, slope is slanting, right? If you're slanting the same, you're never going to hit, right? If you're both vertical, you're both vertical. You're never going to hit. If you're both perfectly horizontal, you're never going to hit. Slanting is perfectly the same. You're never going to hit. Okay? If your slope is the same, I don't have it on the next slide. So let's just write it. Slope is same. That means that you're parallel. Okay? What about, anybody know what these lines are called? So if I have a line this way, and I have a line perpendicular. Does anyone know what the slopes would be like on perpendicular lines? It's a little harder to remember.
It's like 0 over.
Yeah? It's a word that we've used. It's two words that we've used, actually. Yeah.
No solution? Or infinite solution?
No, because there's a solution. It's getting put onto a graph. Infinite would be the exact same line, because there'd be a million points on the same line. Yeah, James? Reciprocal is one of the words, yes. So we can write recip. What's the other word that I said you would mix up with reciprocal? Opposite. Opposite reciprocal. Okay? Opposite reciprocal. So if I was trying to create a perpendicular line to this, all I would have to do is flip the slope and make it its opposite. So if I wanted an exact, I don't have to do this right now, it'll come up later. But if I wanted a perpendicular line to that, all I would have to do is take the slope, make it its opposite, and flip it upside down. So 1/2 x minus 5. Okay, so all I did was take my m, flip it over, and make it opposite. Now if I graphed that, it would be perfectly perpendicular to this line. It would make a perfect cross. Okay, but I think that's not addressed till later, but I figured if it's on here, we can talk about it a little bit. Okay, so any questions on that? Okay, I think the hardest type of problem would be maybe that one. That negative throws people off. Or this one. You just have to get your y by itself and then use y equals mx plus b, which it sounded like right when I mentioned it, it came back to some of your heads a little bit. Y'all remembered a little bit better. Okay? All right. The rest of the time is for you, which is still a decent amount of time. I will post this homework as well.